Good afternoon, students. In this video, we are going to see about the data science lab experiment 4, that is the exploratory data analysis. What is the need for exploratory data analysis? In the data science, you are going to construct some machine learning model or some mathematical model. Then we should know the nature of the data, how the data is spread everywhere, and what is the range of the data, what is the correlation of the data, and what is the mean, median, and the standard deviation, central tendency measure, explore all the things, explore the detail about the data. So exploratory data analysis means explore about the data. That is very, very important. That is one kind of pre-processing before going for any implementation, any model development. Do this pre-processing step. We know that the data pre-processing will increase the accuracy of any classifier, either it may be a supervised classifier or the unsupervised classifier. That is the functionality of this exploratory data analysis. First, you should convert the given data, remove all the duplicates, remove the null values, remove the outliers, all comes under the exploratory data analysis. We'll see first how to remove the duplicates from the given data frame. First, eliminate the duplicates. And second one is analyze the null values, whether there is any null values. If the null value is there, we'll use so many techniques to remove the null values. Third one is outliers. Outliers means the data points which is entirely deviated from the mean value of the data item. It's called as the outliers. We should remove the outliers also to get the efficient output or the effect. To improve the accuracy, we should remove the outliers also. And the next one is to see the correlation between the coefficients. If there is no correlation, then what's the use of that column? We can remove that column also, delete the column from the entire data set. It depends upon the application, whether this is the prediction or the association, depends upon the application. All this analysis varies. First, import the pandas library. Import pandas as PD and import matplotlib as pyplot as PLT. You know that what's the function of this matplot library? It supports the data visualization. Here we are going to check the outliers with the help of some data visualization concepts. Hence, we are using this matplot library. And to find the statistics, right, set square, quartile value, we are using this library STATS from this import SciPy import stats. This one is imported from the SciPy library. So first, we are going to create a data frame from the given data, a table column which gives the employee details as well as the gender, age, sales, BMI, income, and experience. These are the given fields for the table. And first, we are going to create the 2D array. The 2D array is created. Then next, we are going to create the data frame from the array. We have created the data frame from the array. The name is given for each and every column of the array. First one is the employee ID. Second one is the gender. Third is the sales. Third is the age. Next one is the sales. And BMI, income, as well as the experience. These are the given data that is available. From that, I had created the data frame. And this is the data frame created. It contains 0 to 10. That is 11 values are available in this data frame. Totally 11 values are available in this data frame. And here BMI means it is not clear to us, means we'll change that BMI into body mass index. Or MPID, first time you are seeing this one, it's not, you are not interpreting this as employee ID, means you'll change this column also. That is, the column values can be changed appropriate to our application, to our requirement. Here I am going to change this BMI into the body mass index. This. Okay, rename the column. We know that for renaming the column, rename columns. What's the column you are going to replace? I am replacing this BMI with body mass index and in place equal to true. You know the use of this in place equal to true. That means the column name is permanently updated in the given data frame. So update that one. Let's see, will get. Here you see this one is in this data frame. This is the body mass index. That one is now converted into BMI is converted into body mass index. Like that, you can change any columns. You can rename any columns. This is the first step. First rename the values. And the next one is remove the duplicate. When you see here, the employee ID 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is available 2 times. That is the duplicate row because it contains the same information. What's the need for same thing? So we should remove that one. I'm going to remove this one next step. And you know that the basic information can also be found out by using the df.information. It gives the information of the data frame. df.describe. What's the functionality of data? df.describe. It will give the statistical information about the data frame. Similarly, next one is to find the duplicates. To find the duplicates, we are using this df.duplicate. Duplicate dot sum means it will give you the number of duplicate values. To execute this one, we know that number of duplicate value here is only one row is duplicated. So this is this one. And next one is unique values. Find the unique values in this sales column. When you refer the sales column, some fields are there. Here, these are the repeated values. What are the unique values? Unrepeated values. To see that, you use this one, df dot unique for the particular column. Here I am going to find the unique value for the sales column. Hence, I am going to execute df dot sales. The unique values. Here the unique 1, 2, 3, 4, 5, 6, 7, 8 unique values are there among this one. You can see here also. It will give the unrepeated values. What are the values? Actually, what are the values available in the data frame? That is the unique values. And next one is the remove the unwanted columns. Suppose I need only the employee ID, gender, age, and sales and experience. I don't want this body mass index and income for my calculation. In the student database, also no need for attributes and all during the calculation. In that time, we can remove that thing from the database. But you know that how to remove the column or how to drop the column. The column can be removed by using drop command. And the access value equal to column means access equal to 1 and in place equal to 2 means permanent removal. Here you see that here I'm going to remove the income column. Here the income column is removed. Similarly, I may remove any columns. Here if I want to remove this body mass index and income, it's also possible because 0, 1, 2, 3 is the age column, sales column. If I don't want sales and body mass index, I'll remove that. Based on the requirement, I can remove all these things. Now I have removed this income column. These are the basic things, how to remove that, how to rename that, how to find the duplicates, how to remove the duplicates and all. The next is the important one, fill the null values. If the null values are available in the data frame, how to remove the null values. I'm reading the watermelon data set. And here I'm going to calculate the central tendency measures for that one. Central tendency measures means mean, median, mode. You all familiar with that? How to find the mean value, median value, as well as the mode value. Once again, I'll bring that values. This is the mean value, median value, and mode value of the density. Mean value is 0.543 and median value is 0.631. These values are used for filling some null values, are used for replacing something inside the data frame. Instead of taking any value, we can use the mean value also. For that, first we should find the central tendency measure for the given column. The next one is calculator. And the next one is the variability. Central tendency measures means mean, median, and mode. The next is the variability. Variability measures means range, variance, and standard deviation. These are the variability measures. Range means the data set spread from which value to what value. It will give the difference between maximum value and minus value will give the range. What is the spread of range of the data that is spread over that data set? That can be calculated by using range. We know that range is not, we can't find range directly using the function. Instead, it can be calculated maximum value minus minimum value. Here I am calculating the range for the density column. Similarly, VAR is the keyword used to find the variance column. And the standard deviation is also calculated by using the STD column. Execute this one. These values are calculated. Now, from this one, null, I already told you, is null. What is the function of is null? What's the difference between is null means? Is null means it will tell whether it is null or not. Okay. Then is null dot sum means it gives the sum of the null values. It will give either a true or false is null of. If I am executing this one, see here, it's the false, false, false. False means these all are not null values, not null values. If it is a null value, it will give true. So null value is available in the column root in the third row. That is 0, 1, 2, 3, third. In this the fourth row, it's available. Similarly, in the density column also, the fourth row is the null values. Null values, wherever the null values are available, this is displayed by using df dot is null. If you want to see this dot sum means number of null values in each and every column can be calculated. Here in this given example in the watermelon CSV, the root column only one null value, sound column 1, texture column 2, figure 8, 5. These are the null values in each and every column. If you want to see the null value in only one column, you give here the column name, we will get this null value. Next, we are going to replace the null value. First one is replace the null value. Fill null. Fill null is used to replace the null value. Here I am going to fill the null value with 0. Before that, see here, I am going to print the value df. In this df, nan indicates none. So 3, third index, root is none, and as well as the density also, third index is none. Now I am going to fill this null value, density null value with the 0. So fill null of for this one, right? df1 equal to period. I am creating a new data frame, and in this one new data frame, null value is replaced with 0. Here I am placing in place equal to true, so that is permanently updated. Hence only I have created the new data frame. If I run this one, let's see the change. Print that value, the third one. Here this one, the null value is already it's NaN. Here you can find this one, NaN. NaN is replaced with 0. The next one is the fill null value can fill by this different concept. Previous value, if we want to fill the null value, this is the previous value. If we want to fill this null column with the previous value, I'll use this command, fill null of method equal to pad. Pad means previous one. In place equal to true. In this, the null value, the third one of the density is replaced by the previous one. What is the previous one? Here I am removing the null value, only one column, density column, and previous value is 0.634. That value is given in this third row also. Same manner, I will fill it by using the next row value also. That is the B fill value. See, here I am using this B fill. B fill means this null value is printed by or replaced by this. Here you see in this density column, third one is the null value. So if you are using the B fill, then this value 0.556 is the next value. So the none is replaced by 0.556. Again, none can also be replaced by mean, median, mode values also. Here I am using mean for replacing the null values. Already we see that 0.53 something. That value 54. This is the mean value. We already seen that this is the mean value. If this value is replaced in each and every none columns. Median means for the density column, the median value is calculated and the median value is replaced in each and every column. Here instead of mean, we'll use median. Median is the median value. And this 631 is the repeated value, and the median value, that value is used to fill the null value. Again, we can use another one concept called as interpolation. There are so many interpolation methods. We are using the linear interpolation method. This is the linear interpolation. Forward, that means next value and previous value. These two values are taken and that is used for finding the final value. Here the third column, after executing this, the third column contains 6, not 8. So this value and this value, previous and next values are taken and find the average means you will get this value. So this is another one method. Hence, the various techniques used for this filling null values are fill the null value with 0, fill the null value with previous value, next value, mean value, median value, mode value, as well as the interpolation. And the next one is the outlier. Outlier is the point entirely deviated from the data set. The outliers can be identified by 3 visualization techniques. First one is for that one we are using this mat plot. First one is box plot, histogram, and scatter plot. All these 3 plots are used to identify the outliers. In this example, I am drawing the box plot. From the box plot, you will say these 2 are the outliers. When you draw the box plot, you will see the outliers. These 2 are the outliers. Okay. Then, with the help of scatter plot, also you'll find that when you see the scatter plot over here, this is the null. Here, this is the spread of data, and 2 values are entirely deviated from the range, and this is the null value. So this density column contains 2 null values. It's seen by this histogram also. To remove the null values or to calculate the outliers, we are using 2 techniques. First one is by using the Z score. Another one is the IQR. You know that IQR. Z score will give the details of the outliers. If the value of Z score is greater than 3 or less than -3, that is the outlier. When you find the Z score, the statistics is used to find the Z score only. This is the formula used to find the Z score. Z score of density. So Z score will give the stats dot, Z score will give the Z score. Find the Z score of density. Here you see this value, first 0th value and the 4th value. There are 2 outliers. These 2 are the outliers because the value of score is, density score is 3.33 and 3.12. These 2 are the outliers that are shown in the box plot. To remove the outliers, you create new data frame where the Z score value is less than 3. Okay. Take only the values with the Z score less than 3. That will give you the data frame without outliers. So I am going to remove that one. These are the outliers. These 2 are the outliers. And if the density score is less than, and we have created a new data frame where the density score is less than 3. If the density score is less than 3, only take that values. Here that values are taken. These are the value and I am checking the density score. Here all the values, the density score is less than equal to 3. If I plot the scatter plot, I will see that for the new data frame means it's the data frame created with the Z score less than 3. When you refer the new data frame, here the outliers removed. See here all the values are spread in the same range and there is no outliers. Same manner, we can use one more technique called IQR. IQR range also, we will remove the outliers. So this is the syntax of finding the outliers. Q1 means quartile 1. You all know that quartile 1 means 0.25 25% quartile. Q3 means 75% quartile. This can be calculated Q1 and Q3. IQR is calculated. IQR score is calculated by using IQR equal to Q3 minus Q1. If the particular thing is outlier means find the value of lower bound and upper bound. For any data set, the lower bound value as well as the upper bound value is calculated by using L and H values. L value is calculated as Q1 minus 1.5 into IQR and H equal to Q3 plus 1.5 into IQR. So these values are calculated and from this lower bound and the higher bound is evaluated. If any point available after above the H value and below the low L value is the outlier. The thing is outlier means the value of the data is beyond the H value or below the L value. So to remove the outliers, you use this one. If the value is greater than 1 or less than H, greater than L or less than H, it can be removed. So that because that is the outlier. Yeah, IQR value is 0.26 and the outliers are removed. If you see the Z square from that identify, there is no outliers. Similarly, you plot the graph also I'm plotting the graph for the histogram and new histogram. This is the old histogram, first data frame. Here the outlier is there. This is the outlier. And when you're plotting the new one, there is no outlier. All are the continuous data, histogram, continuously distributed. Here one value is entirely deviated from the range. And last one is the correlation. To identify the correlation, so many techniques are there: pairwise correlation, Pearson correlation, then heat map. So many techniques are there. Here we are considering only the heat map. Heat map will give the relationship between all the variables, all the numerical variables that can be obtained by COR equal to df dot COR correlation. It will give the correlation matrix. This is the correlation matrix. The density. Here 1 means there is more correlation and minus indicates there is a less correlation. All the diagonals will be 1 because there is a fully correlation between number column and number column. But high, this dark blue color indicates negative values, indicates less correlation. Positive values indicate medium correlations. Okay. So find the correlation by using this is what called as the heat map. Find the correlation also. So these are the things in the exploratory data analysis. Before doing anything, explore the data. For exploring the data, first rename the values, avoid the duplicates, remove all the null values. Then next one is remove the outliers and find the correlation between the coefficients. That's it. Thank you.